Hello friends, this is Dr. Anand Pai coming again with Physics 101 series. We will continue with part 1, that is mechanics. In that kinematics, till now we have seen the definitions of acceleration, velocity, displacement and all those things. Now let us continue one more point in class 4, which is kinematic equations of motion in one dimensions. We will start with very simple things, and now as we go further, the thing is about whenever we have to use velocity, acceleration in day-to-day activities, we need something called kinematic equations. Okay, these are three equations which will be very helpful for us in whatever calculations we do in acceleration, velocity or motion in one dimensions. Now, what is the assumptions here in one dimensions? Let us see. The first assumption here is obviously it's one dimension, so motion is in one dimension alone, and then acceleration is uniform. Now, what does uniform generally means? Uniform means it does not change with space. But here we will consider that acceleration will not change with space as well as with respect to time. Okay. So therefore, we have A is dv by dt when you differentiate velocity with respect to time, but acceleration as such is constant. V is ds by dt, but here one of the things what has to happen is this acceleration which is there is not a function of time. Okay, so this particular one here, this will not be a function of time. That is, A will be constant. This would be the assumption. Okay, if we change in x direction or if we change in t direction, that means if I draw x versus, that is displacement x versus acceleration, this will be constant. Or instead of x, if I have a versus t, if I have a here and t here, here also it is a constant. That is, its value does not change. This is our assumption. Let us go further. Now, let us go with the first kinematic equations from the definition of acceleration. This is one of the easiest one we can get. Let us see. A is dv by dt. For 1D motion, I can remove that vector symbol. Okay. From the definition of differentiation, we know this, right? Limit t2 minus t1 tending to 0, v2 minus v1 divided by t2 minus t1, that is acceleration. So when I say this, it is just like we have this velocity here and then we have this time here. This is a velocity versus time curve. Okay, so v2 minus v1, v2 minus v1 minus t2 minus t1. When t2 minus t1 is nearly equal to 0, that is the definition of acceleration. Here of course it's very huge, the difference is huge, and that is actually the average acceleration. If t2 minus t1 is very big, then A would be average acceleration. I hope you get the point. Next, let us continue with that. Okay, when acceleration is uniform, the average acceleration is same as instantaneous acceleration, of course, right? When acceleration is uniform, the average acceleration is same as instantaneous acceleration. Why so? Because when we have this acceleration versus time graph, as I've shown that time, acceleration versus time graph, it is constant. Whether you take it an instant or you take it as an average, you will get the same, right? So we will have average acceleration is equal to acceleration is v2 minus v1 divided by t2 minus t1. It is very subtle, but I hope you understand this. Okay, so we can take acceleration and t2 minus t1, we have taken it on the other side. So a into t2 minus t1 is actually v2 minus v. Let us continue with that. That means a into delta t is v2 minus v1, right? So I will write this as v2 is equal to v1 plus a delta t. What did I do? I took v1 to the other side, a to the a delta t here, and then I shifted that. Okay, so this went on the side and this is coming here, v1 plus a delta t is coming here. So what is it? v2 is what? v2 is final velocity. What is v1? v1 would be initial velocity. A would be acceleration into time elapsed. And this is the first kinematic equation. I will call it KE1. Now here, if you observe, I have changed V2 to V, small v, and V1 as small u, and delta t as t. Now, why did I do that? Because this is generally accepted everywhere. This is general notation. We say V is equal to U plus AT, which is generally told. But in my mind, we should have V is nothing but V2, which is final velocity. U is nothing but V1, which is initial velocity. And T is not the continuous time that is changing, but the change in time. Okay, it is not the instantaneous time at that time. What is time now? It is 2 o'clock. So 2 o'clock is the time. Later on it is 4 o'clock. No, it is the difference in the times. That is, we have started at 2 o'clock, we have ended at 4 o'clock. Then the difference is 4 o'clock minus 2 o'clock, so 2 hours. Okay, this is how it has to go. So this is the kinematic equation 1, which is V is equal to U plus AT. Very, very, very important, students. And this is very basics and very important. I hope you will write down in some formula book. Very important to write it on formula books. Now, same first kinematic equation can be got by integrating acceleration function. Here what we are doing is we are going with the different ways to get the same thing, right? Just like religion, there are the various paths to get to the same God. So whether you are a Christian, whether you are a Muslim, whether you are a Hindu, you are anything, okay? God is same, right? God is not different from Christian or Muslim or Hindu. But what happens? The path may be different, right? So similarly, to get to that first kinematic equation, we may go in different paths. So this is the second path of going towards the kinematic equation 1. So for example, A is dv by dt. That is, acceleration is dv by dt, of course. So we can write dv is equal to a into dt. We have just cross multiplied here, right? Now we will integrate it. So dv is equal to a into dt, which comes as v is equal to at plus a constant. What is this constant? That constant is actually the initial velocity. That means when t is equal to 0, v becomes u. And that's why c comes as u. I hope you get the point. So now what we can do? This is one way of getting it. V is equal to at plus delta. Now in case we have gone from 1 to 2, this is definite and this is indefinite. Okay. So when you say definite integration, so you say 1 to 2. From point 1 to point 2, we are integrating and you get the same thing. Okay. And you can write this as V2 is equal to V1 into A into T2 minus T1, which will come back to the same thing. V is equal to U plus AT. So this is how we do that. Here you see dv, when you integrate, I wrote a v here. Okay, I could have written capital V here, but I chose to write small v because it is the final velocity or velocity when the time continues. I hope you are getting the point there. In the sense, see, just a second, students. Okay, so here this v is a function of time. At every time it changes. But how much v has changed? It depends on acceleration into time plus the initial velocity. Hope you got the point. So what is happening here? Here, if you have the velocity versus time graph, velocity is continuously increasing because acceleration is constant. We have seen in the velocity acceleration curve, when velocity time curve, which we got from acceleration time curve, that when acceleration is constant, the velocity versus time graph is having a same slope. So here this one would be u, any point here would be v, right? So what is that v depends on what is the acceleration into the time elapsed between those 2 points. Hope you understood. Next, let us go with the second kinematic equation. Let us look at this. This we are taking from velocity time curve, various parts. Okay. So what is displacement? Displacement is area under the Vt curve, right? So if you have a velocity versus time curve, as we have shown, V1 and V2, V1 is the initial velocity, V2 is the final velocity at 2 times. Okay. So let us do that. Okay. So what is area? What is the displacement? Displacement S here is equal to area ABC, which is the same, right? Plus area OACD. So that would be this, right? So this area would be OACD, would be this area, right? Okay, so this area. So what is ABC? ABC is half into V2 minus V1 into T. Why is that so? Because height into breadth, or breadth into height, and half of it. So breadth is T, wherever this is a T is a variable, so we can take T this anywhere. So whatever the T, what comes there, that T here, right? Plus this area OACD. This OACD is a rectangle, which is V1 into time, right? So that's what we have done. So since V2 minus V1 is equal to 80 from kinematic equation 1, how did we get that? We know that V2 is equal to V1 plus 80. And this V1 has been taken this side, so you get this. This we have got from kinematic equation 1, right? So now if that is the case, I can write V2 minus V1. I have substituted as 80 here. So what's going to happen here, instead of this, I am going to have a t, and this t is multiplied with this t gets multiplied with the t, and we get a t square, right? So area, this area is half into V2 minus V1 into t, and V2 minus V1 is nothing but acceleration into time, so it is half into at square plus V1t, which was already there, and this is actually the kinematic equation 2. Now what is the difference here? As we know that we have changed it as u, right? Because initial velocity v1, it's a general convention that we write it as u, and v2 we write it as small v, right? So s is equal to ut plus half at square. This would be the second kinematic equation, very, very important. First one was v is equal to u plus at. Second one would be s is equal to ut plus half at square, right? Very, very important one. Next, now the same thing in some other way, right? So let us take second kinematic equation from integrating the velocity function. Let us look at that. So from kinematic equation 1 we can write this so. And what is v here? What is velocity? Velocity is nothing but change in displacement versus time, or we can write ds is equal to v1 dt into at dt. Again integrating, we get s is equal to v1 t, because we are integrating this. You see, v1 into t, v1 is a constant, right? Because initial velocity is a constant, and time, when you differentiate, you get when you integrate, you get t dt. The integration is t, ds integration is s, plus here at square. A is a constant, so what is remaining? T dt you have to integrate. It becomes half into t square. So this becomes s is equal to v1t plus half at square, right? So let us continue this. So this is what we get. Instead of v1 we write u. So, and here at square is the same. So this is the same kinematic equation 2, which we get from integrating velocity function. Students, sometimes it is very important that we understand the derivation also, because in problem solving it is very, very important that we understand the derivation. If you understand the derivation, we can do complex problems. Okay, students, now before going to the kinematic equation 3, we will see what is average velocity from velocity time graph, right? When the acceleration is known. I go with the same thing. Displacement is area and the velocity time curve, and displacement is area ABC plus area OACD. Same thing, okay? And the result I have got is the same thing, half into V2 minus V1 into T plus V1T. But what I will do, instead of substituting this as A into T, I will cut this. This is half into V2 into T. That's what I have written, half into V2 into T, right? So I'll write this as half into V2 into T is written here. And here minus V1 into T into half has been written here. And here you have V1 into T. Now half V1T plus V1T will give you positive V1T, right? So you will have this as S is equal to half into V2T, which is here, plus half into V1T, which can be written as V1 into V2 by 2 into T, right? But now, what is, if you take this t down here, that is, we take to the left hand side down. Okay, so s by t is what? v1 minus v2 by 2. But what is displacement by time elapsed? That is nothing but velocity. Which velocity? It's average velocity. So average velocity, which is s by t, will be given as v bar, which is average velocity, is v1 plus v2 divided by 2. And this is very, very important in problem solving, students. Okay, so very, very important. So students, now we will get the third kinematic equation from average velocity. We know acceleration is nothing but rate of change of velocity, that is A is delta V by t, right? Now delta V can be written as V2 minus V1, that is equal to A into t, right? So what did we do? We just take delta V is V2 and that is A into t, because delta V is A into t, right? Or we can write t is equal to V2 minus V1 divided by A. We have just taken this t on the left hand side denominator. Now displacement is nothing but average velocity into time, average velocity v bar into time. We know what is average velocity, v1 plus v2 divided by 2, and time we have derived here, so it is v2 minus v1 divided by a. When you combine those two, we get v2 square minus v1. How did we get this? We got this by a plus b into a minus b is equal to a square minus b square, which is a high school level or primary level algebraic equation, right? Now what we are doing, we are taking 2a over here, so it is 2a, yes, v2 minus v2 square minus v1 square is equal to 2a, yes. This is what is kinematic equation 3. We have taken v2 as u, v2 as v, right, as we did last time. So we have taken v2 as v, v2 as, oh I'm sorry, the capital V. Okay, so the capital V2 we have taken as V, and capital V1 we have taken as U, and V1 we have taken on this side, and you get V square is equal to U square plus 2AS. Instead of that you can write V2 square is equal to V1 square plus 2AS, and that is V square plus U is equal to U square plus 2AS. Let us go further. Now the same thing in a different way, integrating acceleration function, which is very important. Acceleration is rate of change of velocity, of course, but then acceleration changes with respect to distance also. So we can write acceleration as dv by dt is equal to dv by dx into dx by dt, right? But dx by dt is nothing but velocity. Dx by dt is velocity. So we can write acceleration as v into dv by dx. Right. Now what did we do here? We took dx over this side. So a dx is equal to v dv. Integrating, we can obtain like this. We are integrating from x1 to x2, from v1 to v2. That means along a line x where the displacement is happening, there is one x1 here, there is one x2 here, and when it is passing x1 it has a velocity of v1, and when it is passing x2 it has a velocity of v2, right? So when you integrate, I hope you know how to integrate, acceleration into x2 minus x1 is equal to v1 v2 square minus v1 square divided by 2. Further going, we can get this 2 over here, and a is anyhow here, and this x2 minus x1, this distance is what? This is s, displacement. So instead of this we have put s here. So we get 2as is equal to v2 square minus v1 square, and of course v2 square we can take it this side, 2as we can take it this side, and then convert v2 into small v, v1 into small u. We have v square is equal to u square plus 2as. This is how we get by integrating the acceleration function. Students, all these types of derivation we require very much to solve our competitive exams questions, and all these derivations are very important if you have to get the problem solving skills. Now for the formula book. Now what is this? Students, generally whenever a person prepares for competitive exams, he prepares a formula book. Say for example, physics one formula book, chemistry one formula book, maths one formula book, or if he is writing some notes also, very important points also, then those points will be there. And in that case, physics may have 3 or 4 books. Okay. And generally what happens, we have to take a small A5 size book, which is handy to carry. Okay. And in that we will jot down the formulas which we have derived till now. Velocity is ds by dt, acceleration is dv by dt. Acceleration also can be written as v into dv by dx. And v is equal to u plus at, s is equal to ut plus half at square. In between we got average velocities v1 plus v2 divided by 2, and we got v square is equal to u square plus 2as. These three are the kinematic equation. This is average velocity, this is basic definitions, right? So I hope you have enjoyed this video, students. And always one of the main thing what is important is you have to write down all the derivation, all the physics, maths will go to your mind when you jot down, you write again and again, think. Okay, think a lot. Okay, so when you think a lot and you write, then it comes to your mind. So thank you very much. I hope you have enjoyed this video. Further going, we will solve the questions which has come, challenging questions which has come in, which is related to this kinematic equations, or whatever we have done with motion with respect to one dimensions. And I hope you have enjoyed. Any suggestions, any feedback, you can put it in the comments. And also if you want any specific problem to be solved, you can say the problem there, you can give the link of that problem, anything you can do, and I will involve those problems. I'll put that problem in my upcoming videos. So thank you very much. Happy learning. Have a nice day. Thank you, students.